Last time we were here, we learned to decide if a network was traversable or not. How can you tell that a network is traversable? There are two rules.
The first rule is if there are no odds.
There you go. So if every single node has an even degree, good. And the second one, anybody?
There are exactly two odd nodes.
There are exactly two odd nodes. Good. And one of them is a path and one of them is a circuit. Which one? Okay. So what now? Which one's which?
Circuit starts
at one and ends at the same one.
Okay.
One starts at one and ends at the same.
Okay. And which one is which? The even or odd? The one with that's all even or the ones with two odds? Does it matter? Okay. We're not sure. Yeah, all evens you can get back to where you started from, but all the odds you're always going to finish off at a different point. Okay? Good. All right. Well, today what we're going to do is we're going to look at how to get the information that we need from a circuit or from a network, but we're going to look at how to do it from a chart. And it is really important that you're able to read these charts and understand where the information is coming from, because you will definitely see it again. Okay? All right. So what we're going to do is look at how to get the information from tables. You can get an entire network from a table. But most of the time you're going to be given a network to start with, but you may be given some of the information on a table. Remember that every one of the nodes has a distance or a value, right? Some numeric value. And we use those numeric values to find the shortest path earlier. Well, many times those numeric values are given on a table instead of being printed on the actual network itself. And that's what we're going to look at today. So you're going to be looking at some networks, inputting the values from the table, and there are a couple where you're going to draw your own network just from looking at a table. Okay, so let's look at these. This is coming from your Walker Math books. It's networks from tables. The values of edges in the networks are often called weightings because each one is weighted depending on its value. The weightings for a network can be given in table form. I guarantee most of the time they are. So remember that those weightings can have different values. It can be the distances on a map. It can be cost of construction. It can be the time it takes to drive between each city on a map. Lots of different things. But all it is just a number that's put on the edge, right, to tell you the distance or tell you some information about a value between one node and the next. Okay? So this particular chart shows the distances in kilometers between 2 points. Notice they give you A, B, C, D, and E. Those are the points. Okay? And if you look, which one has the most points? Column A, right? It has the most. And then everyone after that has slightly fewer. The one that has the most is going to be a really important value for you. Okay? So keep that in mind as you go. And all you're going to do is simply put the distances between them. So the first column is the intersection of A and what letter? Nobody? Anybody? You betcha. So this one is the intersection of A and B. So the line from A and B has a value of 18. So between A and B, that's right there, has a value of 18. Then the next one down is the intersection of A and C. So A and C has a value of 16. Right, because it's right there, A to C. So all you're going to be doing is finding the intersections to get the values and then putting them on your network. Real rocket science, right? You should be happy with that. Once you get the things on the network, then you get a completed network with all the values included, and then you'll be able to answer questions about it, finding shortest path, etc. Okay? Now, most of the time you see these, you're going to see a different type of chart that doesn't just give you the values in columns. It gives you columns and rows where every single piece of information is repeated. So if you look along the top, this row of names is the same as this column of names. And you're also going to see that say you have Westport to, I should pick names I could pronounce. Reefton, okay? No, well, that one won't work. Let's do Westport or Greymouth to somewhere else because I can't pronounce these names. You want to try it? Okay. So Murchison to, oh, great. That place. All right? So if you look at that, the distance is 50. But if you look at these things, they're always going to be repeated. So you have Murchison here and Murchison here. Is it Murchison here or Murchison?
I think it's Murchison.
Murchison? Okay. In Texas, it's Murchison. Okay. All right, there you go. So you have that value twice, which means that it's going to have two different intersections. But notice that they have the same value. So if you look at the diagonal across here, this side is a mirror image of this side. So you don't need two values for each one. It's going to be the same value no matter which way you read it. Traditionally, we read these things as rows instead of columns. So across instead of up and down. But if they're a mirror image, would it matter if you read it up or down? Not at all. Okay? All right. So either way you want to read it, perfectly fine. Just recognize why they have the two values. It's because every single value here is repeated here. Right? Good. So again, it's just a matter of reading the values that you want and putting them in their respective places. So there you go, Reefton to Spring Junction. Find that intersection. It gives you the value of 45. So put in 45. Notice that they did put in the units when you did that. Units are going to be really important when you're answering your question. If you don't get the units right, then you don't get the answer right. Okay? So be careful about that. Then shows you the completed map. Okay? It's very straightforward. Here's one that shows you the dollar amount in thousands for connecting locations with fiber. So in this particular instance, they just have a bunch of locations, all labeled A, B, C, and D, so no names for them, just letters for them. And we want to draw a network to demonstrate this data. So this one's slightly different. It's going to require a little bit more work. The first step in drawing the network is to select the one that has the most, that connects the largest one. So in other words, the one with the largest degree. And if you look, A has 2 values, so it only connects 2. B has 5 values, so it connects 5, right? Each one of those tells you how many it's connecting. So 3, 3, 3, 1, and 3. So clearly B has the highest degree or the most connections. So that means that one should be at the center of your network, right? Because it has the most connections. Then everything else will simply connect from around that. So let's look at how they draw this. Now, you don't have to draw it exactly the way they did, but notice B had the most connections, so they simply put the B in the center, and then they put in all of the different nodes that connect with B. And you'll remember from when we first looked at networks, you don't have to draw these curvy lines. A straight line is perfectly acceptable. It makes no difference how you draw it. Just make sure that you're connecting all the nodes with their proper connectors. And then you're going to put in the value, the number value, as you go. All right? So after you've put those, then you're just going to place any remaining nodes that don't connect to B. So in this case, D did not connect to B, but it did connect to E and A and C. Does it matter that they cross, that some of the lines cross? Not at all. They can cross if they have to get from one point to another. All right? So you can see the completed drawing there. Don't worry about lengths of the lines. Don't worry if you cross them. Don't worry if, like this one, like D, you're going all the way around to that side. I don't know why they would do that. I would probably just go from there to there, but it doesn't make a difference. And that means your scale can sometimes be very off. So line CD might be very short, but have a huge value. But remember, these things are never drawn to scale, so you're not worried about that. Okay. So, your job today is just to read values from charts, put them on the networks in the right spot, okay? And then they have some networks where you're going to fill in the chart. That is a valuable skill as well, so make sure you can do it both ways. And then you're going to draw a few networks. This good? All right. So your homework, or your classwork, I guess you should say, starts on page 39 and goes through what? So page 39 to 42. Okay? So if you have any questions or need any help, just let me know.